Good afternoon, everyone. This is Kate Loyne-Barron with the APIC's Inland Empire chapter, and welcome to another one of our Lunch and Learn webinars. Today, Quentin Samuelson will do the introduction to blockchain. So very interesting topics. I'm all glad that you're able to attend during your lunch hour. Also, before we get into the presentation, I wanted to remind everyone to go to our website, APIC's Inland Empire chapter, and check out the different events that we have going on between now and the end of the year. And also our spring symposium is going to be on May 5th, which is a Saturday, starting at 8 o'clock. It's a very interesting panel that we have that's going to be speaking about manufacturing, and it's going to be held this year at the Harvey Mudd School of Engineering in Claremont. You can go to our website for all the details. Okay, Quentin, with that, I will have you go ahead and start, and thank you very much.
Thank you. Again, my name is Quentin Samuelson. Just a little bit about my background. I am a consultant these days for IBM, but before coming to IBM, I was basically a practitioner for about 30 years at various different electronics companies. I worked in consumer electronics, automotive electronics, telecom. I worked at a couple of contract manufacturers. So I've done a lot of what all of you are doing now, and I hope I'll be able to give some practical information on blockchain. It is something I've been working with for close to 2 years now, and well, a lot of people have said it's like when the internet came, but it's a little bit more like when the World Wide Web was introduced. Some of us can still remember using the internet before we had, the www prefix, and it was interesting and sometimes useful, but it wasn't until the World Wide Web was introduced that things really got helpful, and everything sort of took off at that point. So blockchain feels like that. So anyway, we're going to try to keep a practical focus for the next hour. I'll give you a quick blockchain 101 introduction just to make sure we're all talking about the same thing, but then we'll focus on use cases and how you make it happen in your company, rather than we're not going to talk about we're not going to use a half hour up to talk about technology or anything like that. So let's move forward. I will mention one quick thing, and that is I will intentionally repeat a few concepts just so you catch them different ways. I've noticed that sometimes that helps with comprehension. So what's blockchain? Yeah, we need to get my slides to change. There we go. Blockchain's a new technology. We all knew that. What it does is it removes cost and complexity from multi-party transactions. If you can remember just that, you will have made some progress. But it does it using a shared, secure, synchronized, and immutable, that means unchangeable, ledger. We'll talk about what that is in just a minute. The best use cases are transferring assets. They can be physical, financial, or virtual, where there are multiple parties involved and where you need some kind of validation of verification. So it is absolutely not a replacement for ERP. You don't need all that validation and verification in ERP. It's best when you are talking about one company working with several other companies at a minimum. Benefits are usually shorter cycle times, lower costs, and increased confidence. Sometimes it can enable a really significant performance improvement. It's reasonably inexpensive to get started. It's not intended to be one of these systems that takes 2 or 3 years to develop, and then you turn it on and go, oh, well, I wish I had thought of such and such. It's typically developed using an agile development methodology, and that keeps it sort of under control. Your partners can be full participants in the blockchain, or they can be sort of just people who interact with the process. And that's important because a lot of us have misperceptions about what will be required in terms of computing power to be online in a blockchain process. It doesn't have to be the case that everybody has a ginormous server farm. We'll talk about why that is after a bit. And finally, we're not proposing this as something that's a replacement for a solution that works perfectly well. Also, if there's no asset being exchanged, or any case where you're talking about, high volume, low value, real-time transactions, it's capable of some of that. But in most cases, if you have a solution that works, you should just keep using it. So the key concept: shared secure ledger that creates a permanent record of transaction. And that ledger is shared between multiple parties. In the diagram you see here, it could be you, the owner of the blockchain, an auditor, a bank, insurance company, government, etc. A lot of times that doesn't make a lot of sense to us. So another way of looking at it is to look at a non-blockchain ledger that most of us have had some experience with, and that's a bank account. This is not my bank account, but it was based on my bank account at one point in time. How is it like blockchain? Well, first of all, it involves multiple parties. It's me, my bank, usually stores, and whoever I write a check to. The ledger is only updated when a properly configured transaction has been received. That means there are some rules that everybody has to follow. One of the differences with blockchain is that the participants, the people who create the blockchain application, they get to decide what those rules will be. Of course, with a bank account, you kind of inherit the rules that already exist in the system. As already mentioned, there are always at least 3 parties, but sometimes there's 4. If you go to Walmart and buy something, well, you're directly interacting with Walmart. They're usually going through a payment processing company of some kind, whether it's Visa and MasterCard or their own bank. And then there's your bank and there's you. So there quite easily can be 4 parties in this. And of course, if your ledger has a particular kind of a status, it may lead to some action. In this case, the action is always by the bank, and usually it's either a notification that you've had a suspicious transaction of some kind, or that your balance is too low, or something like that. But so that most of the key elements of a ledger that's shared between parties are already in a bank account. But basically design one of these to do almost anything. So I built this scenario last year when I happened to be in Tokyo, and those of you that have any familiarity with Tokyo, there's downtown, there's this enormous fish market. Quite conceivably, if you were a restaurant owner in Yokohama, you might go to the fish market and actually select some fresh fish, and you want to have it delivered to you. Of course, if you just have the fish market throw it in a truck and promise that they'll have it to you that afternoon, you don't really know what happened to the fish along the way. You don't know if it was kept at the right temperature. You don't know if the driver dawdled and let the fish get too warm. And you don't know if the driver may have stopped someplace else and swapped out your fish with some lesser quality fish. So you'd like to make sure that that exact same fish makes it from the market to you with the same quality. And if it does, then you'll initiate payment. It doesn't mean you necessarily pay right away, but you'll at least authorize payment. So we can do that on a blockchain by essentially putting a serial number on the fish and then tracking each action as it changes hands, not necessarily ownership, but as it's transferred onto your shipping dock. Then when it's accepted on a truck, so the truck driver might inspect the fish and say, yep, that's 112 kilos of fresh yellowfin tuna, it's the correct serial number, and put it in a refrigerated truck and then actually monitor the temperature, and we could even monitor the GPS location of the truck as it travels from the fish market to your restaurant, so that when it arrives at your restaurant 2.5 hours later, you can actually say, yeah, this is exactly the same fish. I saw the serial number put on, and I can check the sensors that were actually operational while it was in transit and verify that it has been kept in the right temperature range. Therefore, I accept it and will pay for it. So that's a simple example. but you can see what you could do with a blockchain application like that. So most of the benefits come from being able to design applications that solve multi-party problems like that. It's hard to believe in some cases until you remember how dysfunctional some of our processes are, but often it can take transaction time from days down to almost instantaneous. Definitely takes cost out, reduces risk, not always because of fraud and cybercrime, but often just because of misunderstandings, errors, different standards, every party in the process wanting to do things their way, etc. Removing those points of conflict can have a great effect on improving your trust and removing risk. And of course, in that whole process, by being able to do that, sometimes we can open up brand new business models. So the key attributes of blockchain basically are that it's shared. First of all parties can access the ledger. The blockchains are not owned by one organization, they're sort of spread. Blockchain is synchronized and transparent, so those transactions are updated in real time. Everybody can see that they're being updated in real time. Yet they are secure and immutable, and each participant in an application only gets to see the parts of the ledger that are relevant to them. So for instance, the truck driver probably shouldn't know that he's carrying valuable tuna. I think that was about $6,000 worth of tuna, for instance. So you probably don't want the logistics company to know just how much money they're carrying. But at the same time, he has to know what it is, how much it weighs, etc. And then finally, the process is consensus-based and controlled. So we can ensure that the transactions are valid before they are recorded, and we can even build in audit processes and things like that. So that's blockchain 101. The key is, what can we do with it? It solves complex real-world business problems, especially those involving multiple parties. So just to make sure we have mentioned it, Bitcoin is an example of blockchain. It was actually the first blockchain application. It defines basically a cryptocurrency. Intentionally resource intensive. That is done because it is anonymous, whereas business blockchain applications are the exact opposite. They are not anonymous. They're set up specifically to be with named users that we know who they are. So the result of that is that Bitcoin was set up specifically to require extra computing resources. Business blockchain generally does not, unless you're doing really thousands of transactions a day and if you're moving very large amounts of data. Use cases for blockchain will always use some portion of these four elements: a shared ledger, smart contract, trust, and privacy. But I'll tell you where you should use it. What you're really looking for is complex and inefficient business processes. And I often tell people, look for the things that you are frustrated about. Look for processes that make your customer service suffer or your business performance suffer, or that simply take way longer and cost more in terms of time and money than they ought to. That's a good example of a potential blockchain process. Think about going to the DMV and getting a car license or a driver's license, and how complex, often needlessly complex, that seems to be. That's sort of the golden standard. So these are by no means all of the use cases that exist for blockchain, but they are a good sampling of the ones that are relevant to most of us in supply chain management. What you'll see some logos here, and I'll just tell you real quickly. If you see the video logo, that means that there's a YouTube video that I'll give you the links later on, where you can actually get about a 4 or 5 minute explanation of that particular use case and how blockchain enables it. You see the little 1010 logo, that means that there's an IoT or Internet of Things aspect to the use case. And finally, if you see the IBM logo next to it, and there are 3 of them here, those are applications that IBM actually built for our own use. So you can see that we're eating our own dog food. Most of the time, I've been able to split the potential use cases into these 5 categories. And operations and supply chain is the major one. We'll talk more about that one, but we'll also touch on provenance, which is essentially knowing where your stuff came from. Quality and procurement, that basically deals with exactly what you think it deals with. And we've had, frankly, some surprising use cases in that space. Finance, even though we're mostly not finance people, the truth is that a lot of times there are companies dealing with each other where one company has plenty of cash and the other one doesn't. And blockchain offers some interesting solutions in that space. And then finally, engineering. I'm not expecting any of us to need to use that, but if you happen to be talking to somebody from your technical team and they ask, well, what's blockchain? I'll give you at least one example that will be meaningful to them. So the most basic blockchain application is simply tracking where your stuff is. Those of us that have worked in electronics in particular, but in a lot of other industries as well, know that the days when they used to talk about the River Rouge plant at Ford, where they would basically put trees and iron ore in one end and cars would come out the other, and the entire supply chain was really under one factory roof. Those days are long gone. Now an OEM will design a product, but he may have it built by an EMS provider. The EMS provider may not ship it back to the OEM at all. It may ship it to a third-party logistics company's warehouse. From there, it may go direct to the customer. It may go to another warehouse, etc. A lot of times, the OEMs never actually touch the product at all. And ERP systems are really tremendously inefficient at trying to track that. One company I worked at ended up with people calling and emailing all day just to figure out what products were available to ship. The problem is, of course, nobody made a system back 30, 40 years ago that would handle that sort of information. But blockchain does. By this idea of a shared ledger, the EMS provider can add product to that ledger saying, I've put finished goods. Maybe it's in my finished goods section. Maybe I've put it into transit into a warehouse, etc. But I've put that on the blockchain, and then the 3PL maybe is just shipping the product to the OEM's warehouse. So you can see that it passes from the EMS provider through the 3PL's shipping network to the OEM warehouse or to the distribution center. And then when it finally gets delivered to a customer, you take it back off the ledger, but you can track it all the way through in that process. A specific example of this is the joint venture that we IBM have set up with Maersk. We originally designed this just as something for Maersk, and then both companies realized that it was so powerful that we've actually opened it up to when it wants to use it to improve their ability to manage inventory while it's in transit, including whether it's on a truck, sitting at customs, or physically on a ship crossing an ocean, etc. The numbers on the left-hand side are not what has been realized. They are, in fact, some calculated numbers from the World Trade Organization that indicates that worldwide GDP would increase by 5% and total trade volume would increase by 15% if we could just reduce some of the barriers in the global supply chain. Like I mentioned, if you have a chance to watch one of the YouTube videos on this, there's an amazing statistic in the Maersk YouTube video about a simple test we did. We tracked a shipment of flowers from Kenya, where they're grown, to Rotterdam, which is basically where they're distributed from. And we counted the number of reports, forms, emails, and other formal interactions that we had to do to get the flowers just on this simple 5-day journey through the Mediterranean Ocean to get to Rotterdam. It was hundreds. And each one of those, well, all but maybe 4 or 5 were non-value added labor. So you can imagine how we're adding cost and delay to simple shipments, even the ones that you say, oh, it can't be possible, but you know, we've got data to indicate that it really is. Another example of this, one which may be a little more near and dear to some of our hearts, is how you enable supply managed inventory, or some people call it VMI. This is a typical issue when you start separating the various ways, the various stages of your supply chain, and you try to minimize inventory. Of course, the idea is that I'm sorry, it hit my mouse. Let's go forward real quickly. The idea is that you want your component suppliers to ship their products to a third-party logistics managed warehouse, and they retain ownership of the products while they're at that warehouse until you need them and you pull them into your own factory. It actually works really well, but it is a mess to manage because of all the information flow that has to go on just to figure out, because the customer's own factory doesn't have these materials in their inventory yet. Sometimes we'll set up little shadow transactions so they can see them, but it's not easy. But it is with blockchain. You can set up a shared ledger where the component suppliers and the 3PL warehouse are all sharing information about what they have at the warehouse. The component suppliers know what each of them, but not the others, have at the warehouse. The warehouse knows what they've got on stock, and the customer factory can also know what's there. And then when they need the parts, it all gets pulled, it all gets shared on the ledger, and everybody can update their own systems accordingly. And of course, when all is done, then you can have payment that goes direct from the customer back to each of the component suppliers, which can go either through the shared ledger or not, depending on how you want to set it up. So that's an easy way of understanding some of the logistics opportunities. Within the provenance section, some of us don't have to worry as much about this as others, but almost all of our companies at some point have had some involvement in recalls. Of course, the big problem with recalls is narrowing it down to the point where you can minimize the number of actual products that you have to recall. If all you know is that the bad stuff, whether it's food or medicine or cars, if all you know is that it came out of a particular factory in a particular month, you're kind of stuck with recalling everything that was made in that factory in that month. On the other hand, if you can trace the provenance of the parts all the way back to where they came from, and you can now say, well, I happen to know that the bad products, the ones that I need to get rid of, they all came from this one supplier, not only from that one supplier, but from this one supplier lot code. And they were only built into these 565 of my products. Well, now I only have to recall 565 units. I might expand it a little bit for public relations sake or something like that, but I have much more ability to minimize the cost of recalls at the same time as I am very careful to make sure I not only do the recall, but actually track that I've gotten back every product that I recalled. You can go even farther than this, and we've built a demo of an application that does this for automotive, where we could, in fact, pop a message up on the customer's dashboard and say, this car is subject to recall. Please bring it into the repair center within 5 days, and then be able to document when it showed up at the repair center and that it actually had the recall performed on it, so that we would have really exquisite control over that process. And I should mention before I go forward, the automotive companies, since I worked with some of them, they actually solved this problem partly 20 years ago by building big databases used on individual products. They struggled, however, as far as I know, to ever do this in a multi-party process. So every time they had a recall, they could say that, well, it came from this factory of this supplier. They could go back to that factory and have them check their database, but it's still a manual process. With blockchain, we can actually register it on a common shared ledger again, so that everybody has access to it pretty much instantaneously. Also, as one other point on this, most of the processes I've been involved with over the years have been assembly processes. I mean, automotive is very much an assembly process for the most part, and so is electronics usually. But there actually are provenance examples where we're dealing with more of a process sort of a product, and specifically in things like food. Unlike automotive and electronics, where you're basically combining a lot of individual components to make a product, in food we're usually taking either the contents of a farmer's field or an individual animal like a cow or a pig, and we're breaking it down. So provenance can work in both ways. The cool thing is that IBM's actually built a provenance engine that works both directions, and so we can build provenance apps on top of that without any trouble. So I'm going to talk about a couple of a little bit less normal use cases. These are the things that we've been a little surprised with. And the first one is sort of in the procurement space, whether it's more on the transactional side of things. A lot of companies, it turns out, especially in developing countries, never put EDI or web portals or RosettaNet in place, and they don't have a good, secure way to communicate with their suppliers. So, when POs go out and responses come back, demand forecasts, etc., ASNs, they don't have a mechanism for that. And in fact, some of them have begun looking at blockchain as a way to sort of move forward very quickly, understanding that a lot of these processes really are not point to point. It's just OEM to supplier. But often, especially as you get into these bottom ones, we're talking about shipping notice, the receipt advice, invoices, and all that, they often are multi-party processes because there is a third-party logistics company involved. So it can be that you can build a blockchain solution that includes a shared ledger to do both the point-to-point communications as well as the multi-party communications. And of course, you can include logistics. You can also include a bank in this as an example. So there are some opportunities to not to displace functioning EDI and RosettaNet networks, but if you haven't started anything, the blockchain could be a good, not a replacement, but a substitute for those older technologies. Supplier quality data is a similar but not quite the same situation, where really nobody ever came up with a very good way of exchanging quality data that could be standardized across the industry. Part of the reason for that is that quality data takes on very many shapes and forms. It can be process data, it can be parametric data, it can be materials composition data, etc. And many of us solved most of this years ago by certifying suppliers, but there are usually, the last 10% of our suppliers often are providing mechanical parts or are, let's say, inexperienced, and they really need a little more attention. We haven't had a good way of doing that, and we actually did build this for an OEM last year to assist in that process. Now, I mentioned finance. We're just going to touch on that briefly. This actually is one of the applications that IBM built for itself. We have a substantial global finance operation where we help most of our customers. And yet that global finance operation historically had about $100 million of capital tied up at any time. That's a terrible statistic. That's not something we wanted at all, but it was due to the number of disputes we had where we had to resolve situations where people weren't sure they had actually received something, or they thought it was damaged, or whatever. It was taking us on average about a month and a half to resolve these disputes. So for that month and a half, we usually had on average about $31,000 of money sort of tied up. And of course that added up over time to about $100 million. By implementing a blockchain process, not so much for the financing, but simply to eliminate these conflicts, to get rid of as many of these disputes as possible, and then to resolve them quickly when we did have them, not only did we drive the number of invoice disputes down by 60%, but we drove down the number of days necessary to resolve them to less than 10 days. So over 6 weeks to under 2 weeks. And you can imagine how that has improved our availability of net working capital. So you can see where blockchain can not only reduce time, but also and labor, but also real money. And finally, as I mentioned, I wanted to give you one you can tell engineers about. More companies than just these have looked at this, but these are the only companies we've been able to get to actually issue a news release. So blockchain can be used as a secure way to turn things on and off, or even to download fresh software, bring back statistics, etc. Whether you are owner of those items or whether they are, and these two cases basically, they're both in Europe. They're both power grid operators. In one case, they needed to solve a problem where there were so many electric vehicles in that country, and they were all getting plugged in about the same time, that they were drawing too much current out of the grid. You know, you can figure, 6 o'clock to 8 o'clock, everybody gets home from work, plugs their vehicles in to charge, and suddenly they have a minor brownout. So basically what they were able to do with blockchain was turn off the charger for a couple of hours, so they could basically regulate how much power is flowing out of the grid. On the other hand, another power grid that was operating solar batteries wanted to be able to turn on the flow of power from those solar batteries and keep power running all night. So in both cases, they were trying to keep their power grids well balanced. In one case, they were turning off the chargers temporarily. In other cases, they were turning on the batteries temporarily so they could keep things flowing properly. So those are just some examples of the use cases that we've seen in the industry. I'm going to stop for just a second and see if there are any questions that are ready to be asked, and then we'll move on to another topic.
Thank you, Quentin. I'm looking, and currently we do not have any questions. But I actually have a question. If you can speak to implementation a little bit and how it actually comes together.
Yeah, well, that's the next topic. So,
I'm ahead of you.
Yeah.
Okay.
So how do you get started? Well, typically getting started is something like this seminar. We start off talking about blockchain technology. Like I've mentioned a few times, I like to focus primarily on how you can use it, because once you've seen 5 or 6 good examples, most people will start thinking of a process that's kind of like one of those and say, well, can I do this with it? Can I do that? And that helps us move forward in both the your own understanding, and then of course in our or another outside company's understanding of the business problem you're trying to solve. And really, we want to make sure we're talking about a business problem that we're trying to solve, not about, let's just say last year in particular, there were quite a few companies that just wanted to do blockchain so they could sort of get their hands wet. They wanted to have a little bit of experience with blockchain without making a big investment. The days of that have sort of begun to pass away, and most companies now are starting to talk about some real concrete use cases. Typically, we will move on from that to some active assistance in figuring out what use cases that you've thought of might be the best ones to move forward with. And eventually we'll get into an actual project. I think I've mentioned once already that we like to use an agile development methodology for blockchain. That's best for you and it's best for us as well, because nobody benefits if we are, if we build something that is different from what you actually need. A lot of times, I ran enough of these projects myself when I was a practitioner. A lot of times you don't really know what you need until you have gotten partway into the project. An agile development methodology lets you do that by breaking the project down into really small, we call them sprints, where we basically solve one problem after another and we build the application sort of from the core outward. So that's basically how we get started. And of course, once we have something that works well, then we just scale it up so that we just make it so it's more ready for a full-blown production network. I will mention that IBM has now gotten to the point where we have over 3 dozen production blockchain networks that have gone through this process. So it is a real technology, and it's being used by a number of companies around the world. So we'll expand on that a little bit as we go down the next few slides. I know many of you have probably gone through the process of developing a business case, so I'm not going to spend a lot of time on this, but usually it boils down to understanding what the benefits will be and how easy or how straightforward or how low risk the actual project will be. Is it, maybe call it ease of implementation. Often what we'll do is we'll work with the client, and this is still at the beginning. We're not talking about the actual project development yet. We're just trying to figure out which projects are good candidates. We'll try to get a group of people together who have good subject matter expertise. That means not just the vice presidents who know that they need to fix this problem, but the people who are actually executing that process on a daily basis. It could go all the way down to clerks and sort of what we used to call them individual contributors. We'll work with them to get a good understanding of what the benefits are that are the highest priority for the company. That's one of those life lessons you get after a while, that just because in 2009, for instance, it might not have been enough that it saved money over time. In 2009, 2010, I remember we had to save money, so much money that it would pay for itself the same year. So you need to understand what the benefits are that you're driving for this year. Some years it might be improving net working capital, so you're looking at cash flow. Other years it might be profits or cost reduction, etc. We'll take those benefits. We will try to create a set of potential use cases like the projects that are shown there on the right-hand side. And then we'll also look at the projects that would lead to project success. And I've got that, you could think of it as ease of implementation. I've got project success factors down there on the graph. Some of those, of course, are known more to us or your other outside IT company than they are to you, but a lot of them are actually in your own wheelhouse. There's things like, do I have adequate executive support? Do I understand what I want to do well enough that this is a good project? There have been plenty of things where people knew that they needed to solve a problem, but they didn't actually know what they wanted to do. So we'll basically work with you to identify the projects that produce high benefits and have the best likelihood of success. And usually those are the projects that are toward the top and toward the right. So you can see in this case, Project 2 looks like it's almost ideal. It's both high benefit and high ease of implementation. But Project 1 might also be a valid project. We don't really know yet, because once we start further developing these projects, sometimes we find that Project 1 might move to the right, Project 2 might move down and to the left. So we'll often want to look at more than one project at this stage of the process. And then we'll basically help you figure out what your business case is. These are the major categories of items that generally will create a compelling business case for blockchain. It may enable you to comply with applicable laws and regulations or with the customer's requirements. There are plenty of cases, and this is a classic multi-party situation where you have to do things in a particular way, and you have to be able to satisfy the government that you did them properly. So this is a way of ensuring that. It may eliminate a major problem. Could be counterfeit materials, which you eliminate through provenance capabilities, or could be many other things. Saves time, like the example I gave you earlier about a shipping process. May save money, may take a middleman out of the process, or eliminate a non-value added process step, or maybe several. And in a few cases, it may actually enable a new process that would be completely impossible or impractical without some aspect of this shared secured ledger. I mentioned we've already got over 36 production networks, but we've actually done well over 400 individual engagements. Some of these were minor proofs of concept, basically saying, can we try this and see if it works? And some of them were a little bit more involved, and some of them are still in process. We will expect that 36 number to get much, much larger during 2018. We've noticed a few things that often are good indicators of use cases for blockchain specifically. Things like siloed repositories, where we've got many different versions of the truth. Solving that basically to get one version of the truth obviously is going to have a good effect on the process overall. We look for situations where there are multiple companies that are writing to the process. So not just one company executing and sharing information with other companies, but actually multiple companies all interacting with the process. We look for minimal trust, and that doesn't mean that you don't trust your business partners, but it usually does mean that you're not quite sure about the data they're giving you. It may not be anything that is dishonest at all. It may just be that what you call, a transistor, FET, SOT23, so you may describe a part in that way, and your business partner describes it as a SOT23 FET transistor and gives a manufacturer's part number. Same basic data, different order. Maybe it's doesn't quite agree with what you've got, and that can cause processes to stop temporarily. So by creating ways of standardizing the data, we usually are able to improve that process. And that was a simple example, but it really gets bad with customs agencies, for instance. If you're reliant on intermediaries, a lot of, for instance, letter of credit applications are usually reliant on banks and things like that. And we're not always taking the intermediary out, but we're trying to streamline and smooth the processes that are used to enable that. That can make things better. And then finally, we're looking for an actual process. We've got on the slide here process dependencies, but basically it's a situation. First we do step 1, then 2, then 3. We might branch, at one point and say, if this, then do 5, and if that, do 6. But basically, it's a well-defined process that we can execute over and over again. We've got a evaluation framework as well, and you'll recognize some of the stuff that we've already talked about. Initial question: do you have a clear business case? Who are the other entities that you want to interact with? What is the asset that we're managing, et cetera? How many assets are there? How often will it be exchanged? What kind of proof do you need, et cetera? So that all will help us evaluate the individual business case. I'm going to stop one more time, see if there are any questions. Otherwise, we'll move on to a few more slides and then sort of close up.
Let's have a look here. We have a question about the program being recorded. It is being recorded and a link will be provided. We have a question from Jim. How much money should I plan on spending to get through the hands-on activity?
I think that's the second stage, wasn't it? Let's make sure I've got my name. Basically, unless you need to travel to get a bunch of people together in the same place, we typically will not charge you through the hands-on stage. There have been a few small exceptions, but for the most part, we will find a way to provide you with that to get you through the second stage, which is the hands-on stage, without charging you anything. And I'll just tell you, without giving specific numbers, that first project can be really, really small. You know, if we're just sort of tweaking some functionality we built for another company, it can be pretty cheap. But typically, you'll be talking about tens of thousands of dollars for that first project, which is a proof of concept or maybe a small pilot. It could go into the low hundreds of thousands, depending on, you know, just exactly what you want. But we're not talking about multiple millions of dollars at the first project stage. It's when we scale that it could start to get up into that higher range. But again, it depends a tremendous amount on how big your network is going to be, how big of an application you're asking to be built, how much data you plan to squirt through that network. Some of these applications can be pretty tiny, and I know of a few that are pretty huge. So, you know, it really will depend on just how much data you need to move. The one thing I have noticed is that in a lot of cases with blockchain, we're trying to solve some really gnarly problems, but they don't happen that often, and they often don't involve that much data. So the solution to this problem that may have been costing you, you know, millions of dollars a year, the solution may not cost nearly as much as you think, because the tool is so good. You know, it's I'm trying to think of a good example of it. You know, like the first time you got, you know, a socket wrench, and you went, oh gosh, this is wonderful. You know, I've got this old set of box wrenches, and you know, this is so much easier with a ratchet. So it can make a big difference. You had a follow-up question, I think.
Yeah, Trace asked, what are the big ERP companies doing to incorporate blockchain? Companies like SAP and Oracle.
Both Oracle and SAP have initiatives to sort of figure out how they can interact with blockchain. Because of the nature of their processes and their databases, it's a little problematic in some cases. I'll just leave it at that. But that's not to say that they won't come up with usable applications at some point. What we see at this point is companies like IBM that have made a big investment in the technology and sort of our not only early adopters on their own, but we've been working with clients since late 2015. Then there are a host of dedicated application companies that are building a specific blockchain application for a specific industry. And a lot of those are startups, and you know, we would expect that some of them will succeed big and some of them may not. And then there are companies that are trying to work out how to integrate blockchain into their own products. I don't have any slides on it today, but I will mention, for instance, that even IBM has a case like that, where we actually operate the second largest business network. You know, so we actually have an electronic network for exchanging EDI and RosettaNet transactions, and you know, supporting companies even with FTP if they want to do it that way. That historically has always been a point-to-point technology, and our people recognized about almost 2 years ago that a lot of those point-to-point transactions are perfectly legitimate. They work fine, but they would work better if we could somehow make them multi-party. So what we've done is we've opened up our own network so that for instance, if a supplier sends a customer an advanced shipment notification, if they desire, they can make it so that the logistics company can access that transaction through blockchain and can say, yes, not only has company A sent company B an ASN saying they're going to ship 1,000 pieces of such and such, but now I, the logistics company, have actually picked up those 1,000 pieces, and I expect to deliver them, on April 4th. So instead of trying to rip out a perfectly well-functioning network for those companies that are using that business network, they can basically augment it and make it work better. So I would expect other companies will also find the same sort of opportunities.
Another question, what is the best way for me to get my leadership team up to speed?
I'm going to give that to you. We will distribute these slides to you guys as a PDF. I'm just going to skip forward very quickly. At the very end of the file, there's this slide that has a whole lot of these YouTube video examples. There are also a couple of great, and they're a little bit old now, but they're still really good for getting you started. White papers from IBM's, we call it the Institute of Business Value. This is a basic one on blockchain, this one specifically on blockchain electronics. And then further, the very last slide is a simple infographic that talks about what blockchain is. So if nothing else, I know when I do this presentation in person, a lot of times I will print out these two slides and just hand them to people. So they've got lots of links they can follow. And frankly, once you've gone through one or two of these YouTube videos, YouTube will start to suggest more of the same to you. So very easy to find more information. Also, by going up here to the ibm.com/blockchain, you'll get lots and lots of additional help, including, if you want to, there are tutorials, educational materials, etc. And then usually this gives you something that is simple and clear enough that you can show it to an executive in 10 minutes. So hopefully that'll get them started. And beyond that, I've published quite a few blogs on blockchain, sort of pitched at this same level, not too complicated, just sort of get people, get some of these basic questions answered, and they're all on LinkedIn.
Another question, if we start a project in our company, will we be able to connect to supplier or customer blockchains when required?
Yes, maybe not initially. The technology has gotten to the point now where last year we passed from blockchain 0.6 or Hyperledger 0.6, which is the technology that we would recommend, to 1.0. And there are people working feverishly to work out the best ways to connect blockchains to each other. What we're finding so far is that for the use cases that are, let's say, general applications that many people could use and may not need to use a significantly different app, that it is possible to actually sort of move multiple companies onto the same blockchain application, and then we open up something called a channel. So they may actually be using the same blockchain application, but only some people can see other people's transactions that are even occurring. So that you could have a channel, I'm just gonna name some simple names like an IBM channel, a Dell channel, an HP channel, an Acer channel, a Lenovo channel, etc. So just a bunch of computer manufacturers. And none of them would be aware of each other, but they would actually be on the same platform, so they could cross-communicate. That would be one way. Second way is to actually set up communication through a technology like RosettaNet or XML. And then finally, to my knowledge, this is not yet available, but should be available. It'll become available as people actually need to apply for it. the technology basically hook blockchains up, blockchain to blockchain, without the need for any sort of a special intermediary process. So, yeah, the people who are working on it have been working on it for at least a year now, and we expect that that'll become available roughly about the time that people really do need to start connecting blockchains to other blockchains.
Great. Here is another. Sounds like configuration management opportunities in engineering development would benefit from keeping database synchronized. Any examples of improving traceability of mission-critical parts or preventing counterfeit parts from entering the markets?
We are working on both, and I'm going to try to find the specific slides. So here's one. So far, to my knowledge, nobody has asked for this, but it seems like we've got other projects that are doing very similar kinds of transactions, just not for this specific use case between, for instance, an OEM that may have, if you're making a particular electronic product, you could have 10 designs that are all out there in some way. You may have 3 that are being manufactured at different factories, another 3 that are the next iteration of the products at those factories, and then you could have final assembly versions that would make up, in fact, many more than another 3 or 4. Keeping those designs synchronized between the OEM's design staff, which could include external designers, and the program managers, the guys who are actually making sure that the right products are being built at the right factories at the right times, etc. That's a monumental challenge for a lot of companies. I know I worked at a contract manufacturer at one point when I had to watch the design revisions coming off the fax machine when we were still using those for computer boards. The poor guy that used to have to process those ECNs, I'm still amazed he didn't go nuts. At any rate, we know it's a huge challenge, and a shared ledger is just such an obvious way to accomplish that it's not even funny. So that's something that, like I said, I have not seen this particular use case yet. We have other use cases where we definitely are exchanging data as the critical asset. So this is something that I expect will come before long. I'm going to go back to one other spot, if I can find it very quickly, because counterfeit prevention is, sorry, I have more trouble with my mouse. Counterfeit prevention is one of those things that we know is an ongoing issue, where parts may get sold on the gray market, and in some cases may even have been faked in some way so that they pass an initial quality test, but in fact fail in the field, which is the last thing we want to have happen. There is a lovely video on this that's not in electronics. In fact, it came out of the diamond industry, and so look for Everledger on that on that one sheet that demonstrates one way to solve that using blockchain. There are a number of them depending on what the nature is of the part you're trying to avoid counterfeits on. But just leave it said that by registering each device on the blockchain using a unique code, and that unique code is where things really get probably the most distinguished between different applications. That's the basic mechanism.
Great. One last question from Jim. You have done 36 projects. How many are in the works?
Oh, golly. Yeah, so we've got 36 production networks or more, because it keeps going up. I honestly don't know how many more are in the works. At this point, it's dozens to hundreds. Because I honestly just work in the electronics operations of the company, And IBM has industry practices in just, travel, entertainment, and finance, and in agriculture, and a whole host of others. So I can only guess. I would guess we're probably, in terms of active projects, probably a little bit under 100, but that all depends on how you define active projects. We've had well over 400 projects to date, and it seems to be increasing at a geometric rate. So the interesting thing that's happening is that as we develop more and more active projects, we're finding commonality in probably, let's say, over half of them. I think it's actually closer to 2/3 to 3/4, but well over half of them have some element of commonality with past ones. And that means that we're building up a sort of a core of functionality that makes it easier and easier to build a new project. And when we have a truly unique one, even then, in a lot of cases, we've already built the data fields. We know the data elements. We're just combining them in a new and maybe interesting way. So it's getting easier to execute these.
Great, thank you, Quentin. That looks like it for questions at the moment.
Nice timing. Well, in that case, thank you to everybody for your attention. I never turned down an opportunity to hear my own voice for an hour. And if you have further questions, like I said, both at the beginning and the end of the slide set, that you'll be able to get, you'll be able to find my contact information. So thank you again.
Thank you, everyone, for attending the Lunch and Learn. And just remember, this is being recorded, and we'll be sending the links out, and as well as posting it on the website. Thank you again.